For this video, I'm going to be going over problem 3.2. This is one of the problems I kind of struggled with. Hopefully what I say here might make sense. Sorry, excuse me. Basically the problem was talking about a cryocooler, which we're using a thermodynamical principle to transform mechanical work into lower system temperatures. So basically we were trying to figure out how much work is required from the cryocooler to cool down the magnet from 300 Kelvin to 6 Kelvin. Now, the first thing I do when I see numbers, I like to write them down. So it says we're going from 300 Kelvin to 6 Kelvin. So basically what I like to do, I go like temperature initial. So I'd say like the initial temperature, right? Our starting temperature would be 300 Kelvin. Okay, and we're going to 6 Kelvin. So then I have our temperature final is 6 Kelvin. Now, I'm not sure if this is going to be useful yet, but that's just what I always like to start with. And so basically, what it's saying is we assume that the cryocooler is thermally insulated, so there's no loss in the work to heat transfer, and the cryocooler is 100% efficient. So we're not going to be losing any, excess energy or anything from something that, was not stated in the problem. So basically, when I was going about this problem, the first thing I did, I looked at the original problem. In the beginning, there were like instructions. So basically, since we were talking about a magnet, in the original question it said the magnet was equal to 5 kilograms. So I did, I have the mass. This is the mass of the magnet is equal to 5 kilograms. There was also, the beginning gave us information such as like liquid helium at a temperature of 4 Kelvin. They had a specific heat, which was of the magnet, which was 0.3 joules per grams in Celsius. So I will do the specific heat as Cp is equal to 0.3 joules per degree Celsius. So this is specific heat. Right now, all I'm doing is writing down like initial conditions and any information that could be useful. Now, since we're in 5 kilograms right here, and I see that this is in grams, what I want to do is first convert this to grams. So doing like the simple conversions, I'm going to set that equal to 5,000 grams. Now, the first thought that comes to mind when I see all of this, I see specific heat, I see mass, I see initial and final temperatures. So initially, my first thought is MCAT, because here's mass, here's specific heat, and here's temperature. Now in the beginning, those are the exact variables that I have. So in terms of mass, I'm going to be using 5,000 grams. And now in my specific heat, I have 0.3 joules per grams Celsius. And then for delta T, now in order to find delta T, what you have to do is take the final minus the initial. So since we're going from 300 to 6, that means our final is 6 Kelvin, and the initial is 300 Kelvin. So basically, after doing these calculations, first what I have here, let's see, 6, so this is 294 degrees Kelvin, negative 294 degrees Kelvin, that's a change. And so this converts to 20.9 degrees Celsius. So that's the conversion there. Okay, now if I plug this all back in to MCAT, I do, let's just cancel out the variables for a second, make it a little simpler. So what I'll do is I'll just take these out just so we can look at the numbers for a second. So I'll take 5,000 times 0.3, and then I will do times negative 20.9. So this is mass, specific heat, change in temperature. And so when I multiply all of this out, what I then get is, so let's do 5,000.3, so I'll have 5,000, this might be a little easier, I have this part written down. So 0.3 times the negative 20.9 gives me negative 6.27. So I'll have this here times the 5,000 from the beginning. Now after doing this calculation on a calculator, if my math is correct, I would have 350 joules. Now, why do I have joules? All I did was just cancel out these, cancel out the grams. So here's Celsius. So Celsius, like, I had Kelvin here, but I had the Celsius, which I then converted to right about here. So this Kelvin will then cancel out, or this Celsius, sorry, will then cancel out with this Celsius. That's how those cancel out. So you have your Celsius cancels out, you have your grams cancels out, and what's left? Joules. So this is why joules are in your final answer. So hopefully this was a little bit helpful. I'm not sure if I explained it completely correctly. This is how I would explain it and go about explaining this problem. This is similar to what I did on the test, except a few minor adjustments to then, read the question a little more carefully. But yeah, so that was question 3.2. Hopefully this is helpful, or this is correct in any sense. But I guess thank you for watching my video, and I will see you guys in the future.